Hey guys, I am going to go ahead and graph a couple of problems from your worksheet yesterday. I'm going to do problems number 16 and problems 19. Problems number 16 and 19. Okay, so let me put this in presentation mode and I'll put my annotate on. If we look at problem 16, when we're graphing, we always want to start off graphing the parent function first. So let's look. 16 is a transformation on sine of x. So we have y equals, and I'll put number 16 so you know, y equals sine of 3, or y equals 3 sine of 2x. So y equals 3 sine of 2x. Now, let me remind you of our transformations. So the transformations and transform, right? Okay, so the transformations where we had a d plus a sine, or it could be cosine as well, of b x plus and c, and we understood, let's see, that this would be in parentheses like so. All right, guys, so these were our transformations, and the ones that you're gonna be graphing starting out is just a transformation to the amplitude and a change to the period. We're gonna put phase shift in for next week, but let's just start changing the amplitude and the period. And if you look, the amplitude changed how high, or the max and min, not the displacement. It didn't pick the graph up, but it stretched the graph, how high the graph went, how low the graph went. And the period change, it transformed how far out the graph went, or it shrank the graph. And we could find the change to the amplitude and the period by looking at A and B. So as we do this, let's talk about first identifying what our amplitude and periods are. So I'm going to change my color, and I'll look, and let's see, the amplitude on this new one is going to correspond with the number right in front of the trig function. So the number in front of the trig function is 3. So we know our new amplitude is going to be 3. This means our high point and low point is going to be at 3. And let's talk about our period. Our period is going to happen when we take 2 pi and we divide it by whatever the b value is. Well, 2 pi is the normal period, so we're going to take 2 pi, which is what they have, and let's look at what our b value is. Let's see. We got 2 pi, and our b value corresponds with the number that's being multiplied in front of the x. In this trig function, our b value is 2, so we'll take 2 pi divided by 2. We find out that our period is pi. Period means how long it's going to take for the graph to do its thing. Okay, so when we graph these, what we're going to do is we need to first find our new increments, or our points on the x-axis. So we need to find our points on the x-axis. Okay. And we're going to do that by taking the period of the graph. We're going to take the period of the graph and we're going to divide it by 4. Okay, so that's the first step. So our period is pi. And so we need to take pi and we need to divide pi by 4. Okay, so this is going to tell us our increments. Our increments are points on the graph. It's going to start at pi divided by 4. And we need to have 4 points, okay? So there's always going to be 4 points, not including your point at the origin, okay? So not including angle 0. We're going to have 4 angles. So our first angle is going to be pi over 4. And then to find the other 3 angles, I'm going to just count by pi over 4. So my second angle is going to be 2 pi over 4, right? So I had 1 pi over 4, 2 pi over 4. Next one's going to be 3 pi over 4. And my last one is just going to be 4 pi over 4. Now, if you look at this, we can simplify these. My points are at 4, or pi over 4. 2 pi over 4 is just pi divided by 2, pi over 2. And 3 pi over 4 is 3 pi over 4. And 4 pi over 4 is pi. So those are my 4 points, my 4 increment points. And then what I want to look for next is I want to think about what my points are going to be on the parent graph. In this case, my sine values, what my sine of theta is going to be on the parent function. And this is going to help me figure out where my new points go. So on the parent graph, I'm going to go ahead down here. I would normally start at 0. And on this graph, we're going to start at 0, 2, right? So I would start at angle 0. These are all my theta angles, okay? So I start at angle 0, and my sine value, or the sine of theta, would be at 0, right? And I'm getting this from the unit circle. Then on the parent graph, I would go to angle pi over 2, and my sine value would be at 1, and then I would go to pi, and my sine value is 0. And then I go to 3 pi over 2. And my sine value is negative 1. And then I go to 2 pi. And my sine value is 0. Now, what I'm going to do is I am going to take these points and I'll match them with my corresponding new increments. So now, this is what we did in our tutorial today. Now my first point, or my first sine value, is 0. Instead of it being it's still going to be at 0, 0. So here's theta. Here's my new sine values. So we'll still have it at 0, 0. But my next point at pi over 2, 1, that sine value is not going to be at pi over 2 anymore, but it's now going to be at pi over 4. So now my new point is going to be pi over 4, 1. And at pi over 2, it's going to correspond to this pi value here is 0. So now instead of being at pi 0, I'm going to be at pi over 2, 0. So I'm just moving these sine values down here. They're going to match with the angles up here, or my new increments up here. At 3 pi over 2, I was at negative 1. Now it's going to be at 3 pi over 4. And at 2 pi, I was at 0. Now that's going to happen at pi. Okay? Now, here's the deal. I have to change one more thing. I got to change my highs and lows. Highs and lows were at 1 and negative 1. Now I have to change those because now they're going to be at 3 and negative 3. Remember, we have an amplitude change. So I'm going to do one last change here. So I will have the new points at 0. My new angle, my theta. Okay, I will have 0, pi over 4, pi over 2, I'll have 3 pi over 2, and I'll have pi, and then my points are going to be at 0, 3, 0, -3, and 0. Okay? And then I can go ahead and plot those points, guys. And if you want to, go ahead and change it from degrees to radians if you like. So I know that 90 degrees is really just my pi over 2 point. 180 is pi. 270 is 3 pi over 2. 360 is 2 pi. And I'm going to do a darker color here. If I talk about the new increments that I'm going to be using, well, here's angle 0. Pi over 4 is just 45 degrees, so it's just right here. Okay, so there's my pi over 4 point. And then I have 90. There's my pi over 2 point. And then I need 3 pi over, and this should be 3 pi over 4. So I need 3 pi over 4, and that is right here, 135. Okay, so this is my 3 pi over 4 point. And here is my pi point. And then I'm going to just plot my value. So I would be at 0, 0. And then I'm going to be at pi over 4, 3. So let's say 3 is up here. And -3 is down here. So I would be at pi over 4, 3. And then at pi over 2, 0. At 3 pi over 4, I'd be at -3. And at pi, I would be at 0. So the graph is going to look like so. All right, guys. So I hope this helps. And what you're going to do, again, is just go through those steps, find your new increments on the x-axis, and then match those points to the sign values on the parent function, and then from there change your max and mins depending on what the amplitude is. All right, good luck.